look around you, like the room you're sitting in right now, the sky outside your window.
Yeah, even the very atoms making up your body, really.
Right, all of it.
Huh.
What if I told you that absolutely none of this is the fundamental foundation of reality?
It's a pretty heavy thought.
It really is. I mean, what if everything we have ever observed, every star, every galaxy, every empty stretch of space, is just the inside of a fragile, expanding bubble?
A bubble that could completely rewrite its own rules. Yeah.
And without a single second of warning, too.
Right. It is the absolute definition of existing in a borrowed state. Like a cosmic house of cards that feels perfectly stable right up until the moment it just isn't.
Because today, on this deep dive, we are taking you on a journey that is going to radically challenge how you picture the empty space around you.
Oh, definitely.
We're exploring this mind-bending concept called the Matryoshka universe and the actual mechanics of something known in physics as false vacuum decay.
Which is just a fascinating, if slightly terrifying topic.
Yeah, terrifying is the word. Our mission today is to figure out exactly how a universe-ending bubble works. What would actually happen to you if a wall of totally new physics hit our solar system at the speed of light?
Which, spoiler alert, is wild.
Very wild. And we also want to see where the boundary of hard, undeniable science ends and, philosophical belief begins.
Right, because it's a topic that really forces us to completely redefine our physical place in the cosmos.
And to you listening right now, I promise we aren't going to drag you through a dry, overwhelming physics lecture. Think of this as like an awe-inspiring thought experiment.
Yeah, we're keeping it approachable.
Exactly. We are going to look at the very fabric of nothingness, and by the end of this, I guarantee you will never look at empty space the same way again.
Because empty space, as it turns out, is a lot more complicated than just an empty box.
Right.
And that is exactly where all the trouble begins.
Okay, let's unpack this. Before we can even talk about a universe-sized bubble forming, we have to completely redefine nothingness. Because in my mind, a vacuum is just a void. You take a sealed box, you pump out all the air, you remove every single atom, you block all the light.
And the radiation, yeah.
Right, all of it.
Yeah.
And what is left inside is a vacuum, pure nothing.
Well, that's the classical intuitive way of thinking about it. But in modern physics, specifically in quantum field theory, the vacuum is not an empty void at all.
Wait, really?
No. You have to think of the universe as being filled with these invisible oceans of energy called fundamental fields. You have the electromagnetic field, the Higgs field, and so on.
Okay.
They exist absolutely everywhere. So in this framework, a vacuum is simply what happens when all of those fields are at their absolute lowest possible energy state.
Uh-huh.
It's not the absence of things. It's just the baseline resting state of all these invisible oceans.
The resting state. So the space isn't actually empty. The fields are still there. They're just perfectly calm, like asleep.
Precisely. It is the floor of the energy landscape. But here is the core conflict that drives this entire bizarre theory. Physics allows for the possibility of two kinds of lowest states.
Oh boy. Okay.
Yeah. There is the true vacuum, which is the absolute, undeniable bottom of the energy, the deepest possible floor. And then there is the false vacuum.
A false vacuum. I mean, that implies the space we exist in is essentially lying to us.
It is. Let me give you a visual. Imagine a giant, incredibly steep cliff face.
Okay, picturing it.
And halfway down this cliff, there's a tiny, narrow ledge. Now imagine a boulder rolls down the mountain and gets wedged right on that ledge.
Got it.
If you are that boulder, you feel perfectly stable. You're resting. As far as you're concerned, you've hit the ground.
Because you've stopped moving.
Right. But you haven't hit the real ground. You are just in a temporary dip, what we call a metastable state. The actual valley floor, the true vacuum, is still thousands of feet below you.
Wait, I'm trying to picture this. So it's kind of like if I roll a bowling ball down a hill, but it gets stuck in a shallow ditch halfway down.
Yes.
It stops moving. It thinks it's at the absolute bottom, but it's really just stuck in a temporary rut.
That is a brilliant way to look at it. The bowling ball is perfectly content in that ditch, and it might sit there for billions of years without moving an inch.
Wow.
It looks and acts totally stable, but it is fundamentally metastable. All it takes is a sudden jolt, maybe a miniature earthquake, or in quantum physics, what we call a quantum nudge.
A quantum nudge?
Yeah, to bump it out of the ditch so it resumes falling down to the real valley floor.
Okay, so a quantum nudge. What does that actually mean? Do fields randomly jiggle?
They do. Because of the Heisenberg uncertainty principle, the quantum world is constantly jittering with energy.
Right, it's never perfectly still.
Exactly. But it gets weirder. Because of the strange probabilistic rules of quantum mechanics, our bowling ball doesn't even necessarily need to be pushed over the edge of the ditch.
Wait, what?
It could simply tunnel through the dirt and instantly appear in midair on the other side, just falling toward the true bottom.
Tunneling. You mean it just bypasses the barrier entirely, like goes right through the wall?
Yes, quantum tunneling. Because particles don't have a strictly defined, locked-in location until they're observed, they exist as a blur of probabilities.
Okay, my brain is stretching a bit, but I'm with you.
So a tiny piece of that probability blur actually bleeds through the barrier. So given enough time, the fundamental fields of our universe could just spontaneously tunnel through their energy barrier and drop down to the true vacuum.
Oh, wow.
And this is what physicists call false vacuum decay.
That is deeply unsettling. So if this decay happens, does the whole universe drop at once, like boom, everywhere at the same time?
No, and that's where the bubble comes in. It happens at a single, random microscopic point. A tiny bubble of true vacuum nucleates, right in the middle of our sea of false vacuum.
Nucleates, so it just sort of pops into existence.
Yeah, think of it like a raindrop suddenly condensing out of thin air around a speck of dust. But instead of water, it's a droplet of entirely new spacetime.
And because it's dropping to a lower energy state, it's essentially falling. And falling releases energy.
Massive amount, yes.
So I'm guessing this microscopic bubble doesn't stay microscopic for long.
Not at all. The drop releases an unimaginable amount of energy, which pushes outward. The bubble immediately begins to expand at nearly the speed of light.
That's terrifying.
It is. Now, the wall of this expanding bubble is a real physical boundary. It's thinner than an atomic nucleus, but because of all that pent-up energy from the decay, this incredibly thin wall carries terrifying power.
Okay, so an unstoppable microscopic wall of energy is racing outward at the speed of light. But what is actually inside the bubble? Like once the wall passes, what's left behind?
Inside the bubble, the true vacuum is taken over. Because the fundamental fields have dropped to a new resting state, the very laws of physics are fundamentally rewritten.
Rewritten how? Like gravity works differently.
Everything could. Think back to the Higgs field. That field gives particles their mass. If the Higgs field drops to a new baseline, the mass of an electron or a quark completely changes.
Oh, man.
Yeah. The fundamental forces, like the strong nuclear force that holds atoms together or electromagnetism, they might operate on totally different parameters, or they might not exist at all. Even the number of dimensions could be entirely different.
Wow. So outside the bubble, our normal physics still holds. Gravity works, chemistry works, we're all fine.
For now, yeah.
But the instant you cross that infinitely thin wall to the inside, it's a completely alien reality where the literal rules of existence are scrambled.
Yes. The expanding bubble wall is the boundary between two entirely different sets of physical laws. And this matters profoundly because it highlights that the fabric of our reality, the rules that govern how your DNA holds together, might just be a temporary arrangement.
Right.
We might just be the bowling ball sitting in a ditch waiting for a tunneling event to drop us into a new reality.
If the math says our universe is just one of these temporary states, it forces a really uncomfortable question. Could this have already happened?
Oh, definitely.
Like, what if a universe rewriting bubble isn't just a hypothetical future event, but something that is already out there?
That brings us to a mind-bending scenario. Suppose a bubble of true vacuum formed a very, very long time ago in some pre-existing higher energy universe.
Okay.
It is entirely possible, mathematically, that our entire universe and everything we have ever observed is simply the interior of that bubble.
Wait. If we are currently living inside an expanding bubble, wouldn't we see the edge of it?
You'd think so?
Right?
Yeah.
Couldn't astronomers just point the Webb telescope at the deepest part of space and see a giant glowing wall of energy rushing outward?
They couldn't because of the speed limit of the universe.
Huh?
Remember, the bubble wall is expanding outward at nearly the speed of light.
Right.
If this bubble formed before there were any stars or galaxies, in fact, if the Big Bang itself was just the massive release of heat and energy generated when this bubble originally formed, then the wall of the bubble has been outracing us since the very beginning.
Ah, I get it. Because nothing travels faster than light, the light emitted by the edge of the bubble can literally never reach our telescopes.
Exactly.
The wall is always moving away from us faster than any signal could travel backward to show it to us.
Exactly. The wall isn't a physical object in our night sky. It essentially becomes our observable horizon. It is the absolute physical edge of our reality, positioned so incredibly far away that it's permanently beyond the limits of our vision.
Which brings us to the ultimate mind bender, the Matryoshka universe concept. Because if our universe is just a bubble that formed inside some older, higher energy false vacuum, does it stop with us?
It doesn't have to.
Yeah.
If our universe is a bubble, then what we call our perfectly stable true vacuum might just be another ditch on the side of an even bigger mountain.
Oh,
So
Jesus.
it might just be another false vacuum compared to an even deeper, lower energy state.
So just another temporary resting place?
Exactly. Our resting state could decay again tomorrow, forming a new child bubble inside our current bubble. And inside that child bubble, the fields might find another metastable ledge, which eventually decays to form another bubble.
That's insane.
You end up with a cascade of nested realities.
Like a Russian Matryoshka doll, a universe inside a universe inside a universe.
Yes, and every single layer of that Matryoshka doll has its own unique physics, its own totally different particles, and possibly its own strange exotic forms of life.
Right.
But the tragic irony is that observers in every single one of those layers would look around, measure their fundamental forces, build their particle accelerators, and incorrectly assume that their vacuum is the stable foundational one.
Just as we currently do.
Exactly.
So what does this all mean? I have to ask this because I know someone listening is thinking the exact same thing. Let's be real for a second. If this original bubble wall is billions of light years away, and we can literally never see it or interact with it in any way.
Why should we care?
Yeah, exactly. Is an invisible, undetectable boundary even considered real science? Or is it just sci-fi world building for physicists?
That's a fair question. If we connect this to the bigger picture, it absolutely matters. It matters because it redefines the very nature of the cosmic horizon.
How so?
Well, usually when we think of the edge of the observable universe, we just think of it as a limit of time, an empty fade to black where light hasn't reached us yet.
Right, just more space we can't see yet.
But the Matryoshka concept redefines that horizon as a hard physical boundary. It means our universe isn't just an infinite sprawl of nothingness. It is a contained, temporary phase of space-time.
Okay, that is pretty profound.
And mathematically, there is a beautiful, eerie symmetry to the idea of these nested layers. It provides a cohesive framework for understanding how different energetic states can birth entire cosmologies.
Okay, I can appreciate the architectural beauty of a nested cosmos, but let's bring the threat a little closer to home.
Let's do it.
If we accept the premise that bubbles can form within bubbles, that means we have to confront the local threat. What actually happens to you, the listener, if a new child bubble nucleates right here, right next door in the Milky Way, and its wall sweeps through our solar system?
Well, the first thing to know is that you would have absolutely no warning.
None at all.
None. As we established, the wall of the new true vacuum expands at nearly the speed of light. By the time the light from the glowing, incredibly high-energy bubble wall reached your retinas, the wall itself would already be passing through the back of your skull.
So no warning sirens, just an instant light speed transition. But what happens to the physical matter of the Earth? Do we get blown to pieces?
You are not destroyed in the conventional sense of the word. One of the most unbreakable laws of physics is that energy is conserved.
Right. Energy can't be created or destroyed.
Exactly. The sheer mass and energy that make up your body, the Earth, the sun, none of it can just magically vanish. Instead, you are converted.
Converted. How exactly?
Because inside that passing wall, the fundamental rules rewrite themselves. Let's look at the strong nuclear force, the glue that binds quarks together to make the protons and neutrons in your body.
Okay.
If the new vacuum state doesn't support that exact strong force, the glue dissolves. Instantly, your protons fall apart.
Oh, wow.
The electromagnetic force that tells your electrons how to orbit a nucleus might completely alter its parameters, meaning chemistry as we know it ceases to function.
So it just unzip.
Basically.
Yeah.
The raw mass energy that used to be you is still there. The energy tally of the universe stays exactly the same, but the fundamental pattern of your atomic structure is entirely erased.
Here's where it gets really interesting for me. I was trying to picture this, and it's not some fiery Hollywood explosion where you get blown up by dynamite.
No, not at all.
It feels more like someone instantly reformatting a hard drive.
Ooh, I like that.
Yeah, like the raw material is perfectly intact, the metal casing, the silicon platters, the physical hardware of the computer is all still sitting on the desk.
Right.
But the data, the code that made the computer function, the pattern of information that was you, is totally wiped clean and replaced with random noise in a fraction of a millisecond.
That is a phenomenal way to visualize it. The underlying hardware of the universe remains, but the software of reality, is completely overwritten.
Wow.
And the silver lining here is that because the electrical nerve impulses in your brain travel millions of times slower than the speed of light, your brain wouldn't even have time to register the event.
So you wouldn't even know what happened.
Exactly. There would be absolutely no pain, no fear, no realization. You would simply peacefully cease to exist as a cohesive structure.
It's terrifying, but oddly comforting that it would be so quick. But what happens to the empty space itself during this reformatting? Does the bubble just leave behind a chaotic soup?
To understand what happens to space-time, we can look at a concept called phase transition. Think of liquid water freezing into a block of rigid crystalline ice.
Right, the water molecules are exactly the same. They just lose their fluid energy and snap into a highly ordered, rigid, geometric structure.
Exactly. In some theoretical models of quantum gravity, space-time itself has structures and phases. Our current universe might be like a liquid quantum geometry fluid, flexible space that bends around gravity.
Okay.
But the true vacuum inside the new bubble represents a transition into a smooth, deeply ordered, crystallized space. The new child bubble sweeping through us is essentially a growing ice crystal expanding through a supercooled universe.
Wait, so space itself crystallizes. But earlier you mentioned that dropping to a lower energy state releases a massive amount of energy. So inside this new crystallized bubble, it wouldn't be freezing cold like ice, right?
Far from it. The interior of the new bubble ends up filled with blazing heat and incredibly dense, newly forged exotic particles.
But where does all that heat come from if it's crystallizing?
What's incredible is that the heat isn't new energy being pumped in from the outside. It's the latent vacuum energy that was inherently stored in the ditch of our false vacuum.
Oh, from the ledge.
Right. When the space is swallowed by the wall and finally drops to the real valley floor, all that pent-up difference in potential energy is suddenly dumped directly into the interior of the new bubble as violent, blinding heat.
So, to summarize our local threat, a bubble hits Earth at the speed of light, instantly reformats every atom in your body without a shred of pain, and leaves behind a blazing hot universe of crystallized space-time.
That's the long and short of it.
With all these awe-inspiring mechanics laid out, where does it end? Does the Matryoshka doll have a bottom?
It does. There's an ultimate limit.
Right.
Eventually, a tunneling event will drop a vacuum state into the absolute global minimum of the energy landscape.
The true bottom of the canyon.
Yes. This is the true absolute vacuum where the deepest possible floor is finally reached. No further decay is physically or mathematically possible.
The very bottom of the Matryoshka. What exists down there?
At the absolute bottom and the extremely far future of that final bubble, there's only space-time itself. No matter, no radiation, no heat.
Nothing.
Just an impossibly flat, perfectly empty void. In cosmological terms, it would likely become what we call a de Sitter space.
De Sitter space, what does that mean?
It's a model of the universe that contains absolutely no matter and no energy, but still has a positive cosmological constant.
Okay, in plain English.
In plain English, it means it is a completely empty universe that simply expands silently and exponentially forever.
Just a dark, infinite, empty stage with no actors.
Exactly. But before we get totally lost in the existential dread of a perfectly empty eternity, we really have to look at the reality check.
Yes. The moment we ask if any of this is actually real.
Right. And the honest truth from the physics community is this. Currently, there is zero physical evidence for any of this.
Wait, zero?
None. We have never observed a bubble wall. We have certainly not detected any giant crystal lattices in the fabric of space-time.
But what about telescopes?
Well, we have looked deep into the cosmic microwave background, which is the fading, scattered afterglow of the Big Bang, and it is remarkably smooth.
Meaning what?
If our universe had collided with other expanding bubbles in the deep past, those collisions would have left massive, circular temperature scars stamped on the cosmic microwave background. We see absolutely no scars.
Okay, no scars in the sky. What about the rules of physics here on Earth? Could they give us a clue?
They seem perfectly stable. For instance, fundamental principles like Lorentz symmetry hold perfectly firm in every single test we conduct.
Hold on, Lorentz symmetry. What is that?
Lorentz symmetry is the foundational principle that the laws of physics are exactly the same, regardless of how fast you are moving or what direction you are facing.
Okay.
Whether you are standing still on Earth or flying in a rocket at half the speed of light, an electron behaves exactly like an electron.
Makes sense.
If space-time had an underlying crystalline structure from a past bubble event, we might expect that moving in certain directions through the crystal lattice would subtly change how light or particles behave.
Oh, I see. Because you'd be moving against the grain of the crystal.
Exactly. But we have tested this rigorously, and physics remains perfectly symmetrical in all directions. No violations at all.
Okay, but I have to stop you there.
Sure.
If the cosmic microwave background is perfectly smooth, if there are no Lorentz symmetry violations, if there is absolutely zero observational evidence, why are we talking about this?
It's a fair point.
Like, why do brilliant scientists dedicate their entire careers to something that has no physical proof? Is this just a beautiful mathematical fiction?
What's fascinating here is how theoretical physics actually functions and why it's so vital. Science requires ideas that live at the absolute jagged edge of our understanding.
Right.
You see, the concept of false vacuum decay doesn't just come out of nowhere because someone thought it sounded cool. It emerges organically from the mathematics of quantum field theory.
And that's a proven theory.
Arguably the most rigorously tested, highly successful scientific framework in human history. It's the same math that explains the microchips in our computers and predicted the existence of the Higgs boson decades before we actually found it.
So it's like, if you trust the math that makes your smartphone work, and you stretch that exact same proven math to its extreme logical conclusion, it unavoidably predicts these universe-ending bubbles.
Precisely. If you trust the math of the microscopic quantum world, you have to grapple with what that math implies for the macroscopic cosmos.
Wow.
Even if we currently lack the instruments to prove it, these models force us to ask the deepest possible questions. Is our vacuum truly stable? What is the ultimate fate of the universe? What lies beyond the horizon of our vision?
It's the ultimate thought experiment that guides future research. We have to map the edges of the map before we can sail there.
Yes. Claiming that the Matryoshka universe is an undeniable, factual truth would be a belief, not science. But using the Matryoshka concept as a tool to interrogate the limits of reality, that is the very essence of pushing science forward.
Well, we have certainly covered massive ground today. We completely redefined nothingness by exploring the invisible oceans of the metastable false vacuum.
We definitely did.
We peered into the mind-bending Russian nesting doll of Matryoshka universes. And we visualized the peaceful, incredibly swift reformatting of our reality through the phase transition of space-time.
It is a lot to process, honestly.
Mhm.
A universe that is inherently precarious, continually birthing entirely new realities out of the quantum decay of the old ones.
And to you, listening to this, I hope this deep dive hasn't triggered a massive existential crisis on your commute.
Let's hope not.
Whether the Matryoshka universe turns out to be physically true or just a magnificent mathematical dream, it is undeniably a vision that permanently expands how you view the world around you.
I agree completely.
Every time you look at an empty stretch of space, you now know it might just be a bowling ball resting in a ditch waiting for a quantum gust of wind.
It definitely changes the way you appreciate the stability we do have right now.
It really does. But I want to leave you with one final provocative thought. It's a lingering question that comes from the furthest edges of this theory, and we didn't fully answer it today. It's something for you to just mull over.
It's a profound one, too.
If we eventually reach the very bottom of that Matryoshka doll, that absolute true vacuum where the universe is utterly empty, expanding forever in silence with no matter, no radiation, and no physical change whatsoever, does time still actually pass?
It's a staggering question.
Right. Without a clock, without an observer, without a single atom moving from point A to point B to mark a change in state, does the very concept of time still have meaning?
A universe frozen in pure emptiness, with a mathematical clock ticking into infinity.
So tonight, when you look up at the night sky, don't just look at the glowing stars, look at the black spaces between them.
The nothingness.
Exactly. And ask yourself, are you looking at an infinite, unshakable, empty box? Or are you just looking at the fragile, soapy film of a single precarious bubble? Keep thinking about it. We'll catch you on the next deep dive.